Welcome to our discussion on naming binary molecular compounds. In this lesson, we will define some basic chemistry terms, define and learn how to identify molecular compounds, and then convert from symbol to name as well as name to symbol using the naming rules for molecular compounds. Before we dive into our discussion of naming molecular compounds, there's a few broader chemistry terms that we need to be familiar with in order to understand how to name specific types of molecules. The first of these terms is chemistry. What exactly is chemistry? What will we be spending the entire year together studying? So chemistry is defined as the science that focuses on the structure, composition, and properties of matter. Specifically, chemistry focuses on the smallest components of matter, or atoms. So atoms are defined as the basic unit of matter, and they are made up of subatomic particles called protons, neutrons, and electrons. There are, of course, other subatomic particles as well, but we will be focusing just on protons, neutrons, and electrons for this course. The primary tool of any chemist is the periodic table of elements. So, what exactly is an element? By definition, an element is any one of the simplest chemical substances that cannot be changed in a chemical reaction or by any chemical means. And all elements of the same type are made up of atoms that have the same number of protons. So, for example, all atoms of the element carbon have 6 protons, whereas all atoms of the element potassium have 19 protons. So the periodic table of elements shows us all elements that are currently known to man, as well as a few that have been theorized to exist but haven't yet been discovered either in nature or been manufactured in a lab. So now what happens when we take atoms of different types of elements and combine them? In that case, we get a compound. And compounds contain more than one type of element. So for example, water is a compound, salt, sodium chloride, is a compound, methane, CH4, is a compound, because they all contain multiple atoms of different types of elements. We can also have molecules of certain compounds, as well as molecules of certain pure substances. So molecules are the smallest identifiable sample of a substance. So using water as an example, water is a compound, but I can also have one molecule of water. When I have one molecule of water, I have 2 hydrogens bonded to 1 oxygen. I can also have molecules that are only made up of one type of element. For example, a molecule of oxygen gas is composed of 2 oxygen atoms bonded together. Finally, our last 2 terms are ions and isotopes. So as we mentioned, atoms of the same element have the same number of protons. That's not going to change, but sometimes our numbers of electrons and neutrons can change, and when that happens, we get ions and isotopes respectively. In a normal atom of an element, we have equal numbers of protons and electrons. But sometimes, if we lose or gain electrons, we form an ion. So ions are atoms that have unequal numbers of protons and electrons. When we have more electrons than protons, we have an overall negative charge, and we call that type of atom an anion. If we have more protons than electrons, we have an overall positive charge, and we call that type of atom a cation. Finally, when we have different numbers of neutrons, we have something called an isotope. So again, our number of protons will be the same, but our number of neutrons may differ. Again, using carbon as our example, a typical atom of carbon is going to have 6 protons and 6 neutrons. So an isotope of carbon could have 6 protons and 7 neutrons, or 6 protons and 5 neutrons. So now that we've covered some of the basic terminology that we'll use throughout this course, there's one more thing we need to understand before jumping into naming, and that's how to identify metals and nonmetals using your periodic table. So your periodic table actually makes differentiating between your metallic elements and your non-metallic elements really easy. So the first thing you got to do is find your ladder. And your ladder is this squiggly line right here that starts between boron and aluminum and goes all the way down to tellurium and iodine. Everything to the right of that ladder, everything on the right-hand corner of your periodic table, are your non-metal elements. And everything else to the left and below are your metal elements. So non-metals to the right, metals to the left. In order to keep everybody on the same page, regardless of where they are studying or practicing chemistry, we have rules about what to call chemical compounds. So the first type of chemical compounds we'll be naming are binary molecular compounds. So binary molecular compounds are made up of only non-metal elements. When we name them, we're going to use prefixes for each element within the compound, and our overall name is going to end in "ide." So these are the three rules we need to keep in mind when naming our binary molecular compounds. All right, let's take a look at a couple of examples and practice naming our binary molecular compounds. So for our very first compound, we have H2O. So the very first thing we have to do is make sure that we have a nonmetal and a nonmetal. And sure enough, hydrogen is a nonmetal and oxygen is a nonmetal. Do be careful, even though hydrogen is on the left-hand side of your periodic table, it is the one exception. It is a non-metal, even though it's on the left-hand side. So in this case, we do have a binary molecular compound with a non-metal and a non-metal. And our second rule states to use prefixes for each element. And this is our list of prefixes right here. And our prefixes are based on the number of atoms we have. So since we have 2 hydrogens, I'm going to use the prefix di. So it's going to be dihydrogen, and I only have 1 oxygen. So it's going to be dihydrogen monoxide. And remember, all of our binary molecular compounds end in "ide, so that's why we stuck that "ide" on the end of our name for H2O. So let's take a look at our next example, CO2. We have another nonmetal, so we can continue using these same rules. But we have only 1 carbon in the beginning as our first element. So it would be a little awkward to say monocarbon. So when our first element is by itself, we can actually just drop that mono and simply say carbon, because that will tell us we have only 1 carbon atom in this compound. But for oxygen, we have 2, so we need to use the prefix di, and then we need to stick "ide" at the end. So the name of this compound, as most of you already know, is carbon dioxide. And for NO, we have 1 nitrogen, so we're going to leave out the mono, and we have 1 oxygen, which we are going to add the mono to, and then "ide" at the end. So NO is going to be nitrogen monoxide. Pause the video, give SBR6 and N2O5 a try on your own, and then when you're done, hit play and you can check your work to make sure you did it correctly. All right, so check your work. For SBR6, you should have had sulfur hexabromide, and for N2O5, you should have had dinitrogen pentoxide. So for that one, we have multiples of each element, so each element needs to have its own prefix. No dropping prefixes on that last one. So now that we know how to go from symbol to words, let's try going backwards from words to symbol. So for the first one, chlorine monoxide, since there's no mono on chlorine, we know that it's just a single chlorine atom, and because oxide has a prefix of mono on it, we know that there's also only 1 oxygen. So in this case, our symbol would be ClO. For diphosphorus pentoxide, we have prefixes on both. So for diphosphorus, we know that di is the prefix for 2, so we have 2 phosphorus atoms. So we're going to write that with a P and a subscript 2, indicating that we have 2 phosphorus atoms in this molecule. And then pentoxide, pent is our prefix for 5. So we have 5 oxygen atoms in this molecule, and we're going to denote that by writing are oxygen with an O and a subscript 5. So diphosphorus pentoxide, P2O5. So go ahead and pause the video and try krypton difluoride on your own, and then when you have it, hit play to check your work. All right, so there you go. For krypton difluoride, you should have gotten KrF2. And that concludes our discussion of naming binary molecular compounds. Bring any questions you have with you to class.